Hello. Thanks everyone. Thanks everyone for attending this talk today. So today we're going to start the talk a little bit trying to find out a little bit about what it means to build a functional reactive application. We're going to try to understand why we're interested in doing this, why we bother. And then the idea is that I'm going to be showing you a little reactive application that I wrote, and I'll be doing a bit of live coding so that you get a bit of feel of how it works. So as the presenter said, my name is Galder. I work for Red Hat as an engineer. I primarily work on Infinispan, which is an in-memory data grid from Red Hat that I co-founded back in 2009. I currently lead the client-server architecture. I write code in many languages. I like Java, Scala, JavaScript, Haskell, Elm. So I'm very keen on those programming languages that promote functional programming. If you want to find out more about myself, you can find me on Twitter at Galder.Z. And if you have any comments about the talk, you can use the hashtag GIDS17 or Infinispan, and it'd be great to hear what you think of this talk. So before I go next, I wanted to find out a bit about you. So I want to do a little bit of a raise hands, okay? So how many of you have developed with JavaScript? Okay, so pretty much everyone. What about Java? Any Java developers out there? Okay. What about Node.js? Okay. What about Haskell? One. Elm? Okay, good. So with that, that gives me a little bit an idea of what kind of technologies you've used in the past. Most of this talk today is going to be focused a little bit in the front end. So there's going to be less of the Node.js, less of Infinispan. But hopefully you'll get a good feeling for what you can do. So the idea for today is to kind of learn how to build functional reactive applications. But before we can learn how to do that, first we need to see what does it mean to build a functional reactive application. So we call functional reactive applications those applications that are constructed using functional reactive programming. The problem is that defining functional reactive programming is a bit difficult because it's an abstract concept. And if you go online, you'll see a lot of questions on Stack Overflow about what is it, what does it really mean to do functional reactive programming. My view is that the best way to explain a concept like this is to split the question into two. To say, well, first of all, what is the actual definition of functional reactive programming? And the second part really is, why is it interesting? What is it useful for? Why do we care? Why would we use it at all? So if we look at the definition itself, FRP, or functional reactive programming, is a composable declarative way of programming with time-varying values, so with values that change over time. The composable declarative part is what gives the functional aspect. And reacting to value changes, that's what we call it reactive. That's the part that is reactive. So if we look at this part more closely, we see that the idea of functional composable declarative computation is defined by having programs, so developing software in a way that is structured like this, where you take an input, you apply some combinators, so you transform it in some way, and then you produce an output. And then the output often becomes the input of another computation. So the idea is to take input, combine it to output, then combine it with input, combine it, output, etc. for this. Now, if we combine this kind of idea with reactive, what do we do? What do we end up to? We end up like having that input tends to be some kind of event, so something that's happened, along with the state, the current state of the application. Then you apply some transformation, which could be result in either new state, like an updated state, or it could result in an event being sent, or it could be a combination of the two. So it's this idea of building the kind of input, combinate output together with reactiveness. So you get time-varying changes, events, and then you combine them along. Now, the second part of the question was, why is functional reactive programming interesting? And there's several reasons why it's interesting. It's not just a single one. First, building composable systems makes it easier to reason about the different orchestration. That is because we end up often building complex pieces of software. So constructing it in this way makes it easier for us to understand them. Another interesting key aspect of functional reactive programming is by design, everything is asynchronous. So there's never any situation where you're waiting for a reply. So what you do is you let your application be driven by the state changes. So what this means is that by making everything asynchronous, you basically get better efficiency because you're not waiting, you're not holding on to threads, to any logs on the data. And in the end, what you end up, by improving the efficiency, what you end up doing is you can do more with less hardware, less software. So the idea for today is that I want to show you a little bit how we can build a functional reactive application. And the best way to do it is just to go and build one, really. So what I've built is I've built a little sample application that is going to show us the upcoming Infinispan conference talks that are happening around the world. So it's just a little crude application, but it has a few principles. It uses a few of the FRP principles, which I think are very interesting. So we'll be able to see all the upcoming talks. We'll be able to insert one. We'll be able to even query potentially, and we'll see how we can deal with events as well. So this application, I don't know whether you guys can see very well, but it's essentially formed of a front end, which is written in Elm. And this one is going to be talking to via HTTP with a middle layer, a stateless layer, which is written in Node.js. And then in the backend, it's going to be talking to Infinispan, which is an in-memory data grid. So it's like a persistent stored in persistent data kept in memory. So let's look at each of the layers independently so you get a bit of better understanding how it all works. On the first part, we've got Elm. Elm is essentially an statically typed language for building user interfaces. Why do I talk about Elm? Why today? Because I really like statically typed languages because they allow me to catch mistakes early on. They are typed, so it means I can use the types as a guide for my development, and they also act as documentation. And more importantly, it helps me a lot with refactoring. When I want to refactor things, move around, the fact that it's statically typed really helps me figure out what is wrong. As I said, what do we use it for? It's primarily used for building user interfaces for the web. It's also a purely functional programming language. So it means that you never really have in your application any mutations or any side effects. All you're doing all the time is take something, transform it, and basically create something else. And it's a language that promotes functional reactive principles. So we got a statically compiled language. What does it compile to? JavaScript. And one of the cool things it has is that it's very clever in the way that it produces the JavaScript, and it can render user interfaces faster than other competitors, such as React, Angular, or Ember. One of the things that it's very well known for is its compiler errors. It's known to have the most helpful compiler errors in the industry. So, and everyone that develops Elm has this feeling that if it compiles, it pretty much works. So you even after a serious refactoring, you're quite confident that it will work. And in general, this makes maintaining Elm-based applications much nicer than large JavaScript ones. So one of the cool things about Elm is that it does not produce any runtime exceptions. So I saw earlier that there's quite a few JavaScript developers. How many of you have you seen undefined is not a function error? Everyone. It's horrible. It's the worst error you can get. You never know what is wrong with it. Have you misspelled something? Have you forgotten to pass a parameter? I mean, I was doing a live demo a few months ago, and I actually was doing live coding of Node.js application. And I made a mistake, of course, and I was like, I couldn't see what the error was. And thankfully, someone in the audience helped me, but I always have so many issues with Node.js. So I still used it for the demo, but yeah, we're humans after all. So in the middle here, I've got a little stateless layer based on Node.js. This acts like a little bridge because at the backend I'm using like a Node.js client to talk to the data store. What is it built on? It's built on Express.js. Do you know Express.js? Yeah. It's like a minimalist web framework for Node.js. Now, Node.js itself does not explicitly promote functional reactive programming. It's true that there is a synchronous, event-based, so it does enable you to build functional reactive application. But the problem here is you need to be very disciplined in the way you go about coding. So you need to avoid mutation, avoiding side effects. So you need to be quite disciplined. This stateless layer here is going to be listening on HTTP port 3000 for our demo. And then in the backend, it's going to be talking binary with the data grid. It's got like a client that basically can react, can basically send it can send the data to the nodes in an intelligent fashion. It can react to any backend changes when there is nodes going down, if they're shut down or whatever. It's very, very cool. So what do we have in the backend? In the backend, I've got an in-memory data grid. So these are basically servers running essentially Java that are using the heap as a way to store the data, which you can then you can back them with persistent store if you want to. Infinispan is an open source project. It's based on Apache 2 license. And in the demo today, I'm going to be using a 3-server domain, node domain, where the nodes are going to be communicating with each other, and it's configured in such a way that it always keeps 2 copies of the data. So if we have time today, we'll see what happens if we crash one of the nodes, and you see how it behaves. To interact with it, you can interact with it from Java, from Node.js, like we're going to do today in this demo, from C, C++, we even got some clients in Ruby or Python. And one of the cool things from FRP perspective is that it supports remote event listeners. So that means that the clients can attach listeners to know when data has been inserted or when it's been modified or deleted. And this is quite a nice functional reactive programming feature because it allows you to react to changes based on events rather than mutations. To understand the demo today, I wanted to explain a little bit what how an Elm application works. I don't know whether you can all see it, but essentially an Elm application is divided into 3 parts. The first part is what we call the model. Here we define what our model or state of the application, okay? So what is it that we want to keep as a state? In this here, this is how do we find a very simple method. This is a method called model that returns, this is just the return type. It doesn't have any parameters, just returns model. Here is kind of the initial values of our state, kind of your initializer. Then what we have is events. The way we define events is by having this kind of type message. this is here is what we call a union type. So it means that the message of the event is one of these types. So it's going to be either clicking a button, typing something into a field, sending an HTTP call, receiving a WebSocket event. All of that is modeled as an event. And then what we have here is an update function. Here, so that for the signature, the way it works is this is a method that takes two parameters, message, which is the event, and the state. So you remember the input parameters of the state and the event. And what it returns is a tuple. So basically, this is the output, which is a model, which could be updated, and it can basically send new events. So as I said, you can either send a new state, you can send an event, or you can send both, actually. And then here what we have is how we deal with each of the events. So in the update, this is what we call pattern matching. So if we get an event, instead of type click, this is what we do. Is this HTTP HTTP response? This is what we do. If this is we've typed something into a field, this is what we do, and we'll see that in the demo. And then here at the bottom, what we have is the view. View basically takes the state and produces HTML. And the interesting thing about this return is that it's an HTML that can produce events. That is because from an HTML, we can do clicks, we can do adding data to the input. And then here we basically define what our HTML looks like. Now, to understand how it all binds together, I created a little sequence diagram that should help you understand a little bit. Hello? Hello? Okay. So, behind all the magic, there is something called an Elm runtime. What it does is, this is the power of the Elm applications. You never really invoke directly these methods. The engine itself calls you into it. So you never have to worry about calling anything, really. It just calls onto you. So let me just give you an example of how it works. So the first time it starts, it takes the model, so this state here, and it kind of passes it into a view method. Then we we say, this is the HTML I want you to show, and then I know from my HTML that I support clicking a button. So then the user goes, clicks a button, and then what does the Elm runtime do? It takes the click event, the state, and it sends it to the update function, this update function that you see here. And inside of it, I decide what do I do with my click. And then say, for example, I send an HTTP call. So that HTTP call goes into wherever it goes, and then I have a way to say when the response comes back, that's going to come as an event as well. So I'm going to get the response event plus the state, and that's going to be invoked into my update function. Then here, I'm going to have another kind of case to say, what do I do when I get an HTTP response? And I can say, okay, maybe in my case, I want to update the state. So then I update the state. The Elm runtime says, hey, the state has changed. So what does it do? It takes the state and passes it on to the view. So the view then shows it. Is it understood, more or less? It's a little bit difficult to start with. But this is the essence of how Elm deals with the application. And we're going to see this in action today. Okay. The demos, I've got about 2 or 3 parts to show, depending on how we do with time. The very first part that I want to show is what happens on a startup. On a startup, what we are going to do is our front end is going to basically do an HTTP GET to the middle layer saying request events. So the idea is we want to see what events we already have in the system. And then it will send that, and then the backend, then the middleware is going to basically call, it's going to iterate over the contents in the data grid, and then the data grid asynchronously is going to send all the events to the middle layer. The middle layer then is going to put them all together and then send them as a JSON, an event array back to the front end. And the front end then is going to show it to us. Okay, so this is quite a nice, cool, simple start. Right, so let's see this in action. Right, let's go this place. Can you mirror? Right. Okay, I can now mirror. Okay, let's go. Can you see my application a little? Is that big enough? Like this? Yeah. We just got. So this is what my application looks like at the moment. I've got my front end, just a little bit like a banner, and then I've got some information about websites. So the idea is we want to make this application show the upcoming talks. So the ones have a store in the backend first. Now, the first thing that I need to do, I need to go and implement something because clearly there's something missing there. Right, so is that big enough? Okay. Okay. Is that big enough in the backend? Yeah? Okay. So let's see where we are. Right. So let me start from the top a little bit easier. So here we've got what our main application is. Now, so that you see, I've got my, this is my backend data grid. Then this project, which you'll see is I've configured with Webpack. So it means that whenever I make any changes to my front end, then that's going to recompile it and it's going to basically update it. And then, so our application currently, it's got a starter application, so it's got some imports here. And then here is how we define our HTML application. So it's got an init function, a view function, update, and there's one extra thing which I haven't talked, which is subscriptions, and I'll explain that a bit later. So here we've got the state of the application. So for the first demo, the interesting part are these two. We got talks, which is a maybe of a list of conference talks. What it means maybe is either a type that is either something or nothing. The reason I use maybe here is because at the very start I have nothing, because at least the list of conference talks could be empty. So I need to find a way, like I still don't have anything to show you. And then even errors that I get from the server or any errors that might happen, I see it I have it here mapped. Now, here in the model, what I have is the initial model. This is my initial state. Later on, we're going to be able to add a new talk, so then I've got already preloaded some data for me to have. Now, the init function is what happens at the very start. So what does it do? It says, I want my starting application to have this model, which is this state that you see here, but at the same time, I want to, when I start, I want to send an event. What's the event that I want to send? I want to retrieve those events from the middle layer. So, how do we do that? Well, the first thing that we need to do is we need to define where do we need to fetch our events from. And this is going to be in here, localhost, and then I'm going to be getting it from events. That's kind of how do you define a little local variable, okay? And then what I do is I'm going to be use my URL to do what? To do perform a task. Now, what is the task I'm going to perform? It's going to be an http.get. Okay, but this is not enough. I need to give it a few more things. First of all, I need to say, what do I need to get? I need to get my URL, okay? But when I get a URL, what am I going to be getting? Well, I need to define a decoder. What is it that when I fetch something, what am I going to decode it? And then here I've got already a method, which, one second, talks decoder. That what it does, it basically takes the JSON that comes from the backend, and then that's going to convert it. Okay. Basically, all it does, it takes the JSON and it converts it into my state. So it's basically JSON to my state decoder. So that's the decoder, but this is not yet finished because, as I said before, when we send an HTTP request, I need to get what is the event that this is going to produce. It's going to produce either of two events. It is going to say this get talk succeeded or get talks fail. So what you see here is that a space in L means that's what you call a parameter. So here, HTTP get is a function that takes two parameters. And then perform is one that takes three parameters, 1, 2, and then this final third one, okay? Just so that you understand. It's not like in Java where you do something, dot, the name of the method, and then you have the parameters. So this is ready. Now, let's see what happens. As I said before, I've got a Webpack that basically whenever I make changes, it updates. So let me see if I can, now I've saved it, and then it tells me there's an error. Ooh, so you start to see the first thing. What's the error that I've made? So perform is an error because I made a spelling mistake, it's perform. So if I go here, I can just fix that. And then that works fine. So if we go to the front end, we see it's automatically reloaded the front end. And then what we see here is network error. So the reason I get an network error is because I still haven't updated, I haven't started the middle layer. So I'm trying to show you here, this is how you deal with failures. And the way we've dealt with failures is in the same way that we deal with successes. So as I said before, if there is any failure, I said, I need to do get talks fail. So if we get talks fail, oops. So if we define an event, get talks fail, that takes parameter HTTP error. So if I get an HTTP error, what do? I take the talks error and update it. So that's how I'm basically dealing with the failures, just like any other events, just like success. And you have no choice. If you forget to deal with the error, you'll get a compilation error. So that's amazing. Every time, you never really are in a situation where you forget to deal with the error and suddenly it goes vanishing. So you see here how I've got an HTTP error because the middle layer is not there, so I've just put it here. Now, let's, what should we do? We should really need to start our middle layer. So here is the layer that I've used Node.js. It's started. So now let's restart this, and we start to see we already got the upcoming talks. So these are the talks that are given in the next few months, and we see that they're all there. Okay? So we've got our first demo working. So let's go back to the presentation. Oops. So the second talk is the second part of the demo is a little bit more interesting. What we're going to do is we're going to be inserting a new event or a new conference talk. So the way it's going to work is we're going to go from one of the windows. We're going to send a post. HTTP goes to the middle layer. The middle layer then is going to do what we call a put if absent. So it's going to say, put this into our data grid and then tell us if the event was present earlier or not. And then what it does is going to say, well, okay, the event was stored, yes, no. But on top of that, the middle layer has got registers a remote listener with a backend. So that means that if I store something, this middle layer is going to receive an event. It's going to say, this new event was created. Now, why do I do this? It's because by doing this, I'm kind of promoting FRP principles. As I said, we want to always deal with changes as an event. So you get the events and the state, and then you deal with it. And then this helps us to do a couple of things. A, it allows us to update the state in the originator via an event, the way we want it. And on top of that, by combining it with WebSockets, we can very easily then send an event to any other browsers that we have communicated that a new event that's been created. So we can use it for a couple of very, very cool things. And Elm as well has got a very, very neat way of dealing with WebSockets. That is super simple. So let's see this in action. Right. Okay, let's go back to my. Let's go these two. Okay, right. So for this part, second part of the demo, what I'm going to do, so that you see that I'm not cheating, I'm basically going to start another window. So I've got here one window in Safari, one wall in Chrome. Okay. So we know that I'm not that I can see whether WebSockets are really working. Right. So the first thing that I need to do is I need to say, well, first I need to have the ability to insert a new talk. Okay. So what do we? Sorry. So the first thing that we need to do is say we're gonna present. Eventually, we're gonna have like a dialogue, like that where we type out the data, and then we're gonna have be able to click on a button to say insert this event. So as I said before, any events are dealt in the same way. So here we have our previous. This is kind of the update function with all the different events that we can deal with. Earlier we said how we deal with the get talks failure. So now what we need to do is how do we deal with the inserting a talk. So what happens when we insert a talk? What we're going to do is we're gonna do an HTTP post, which I've defined it in a method already, so I didn't have to I didn't have to basically do this manually right now. And then what we are going to do is we're gonna say any fields that are in the state about, I'm gonna take, so any state that is, so all the fields that are part of my insert, the insert dialog, are part of the state. So if we go up, we say all these fields are basically the state of what I'm going to be inserting. So what I need to do is I need to take that state and I need to convert it into JSON. And JSON, this is what insert talk as JSON does. It produces the JSON. And then the perform insert tag here is going to be, what is it going to be doing for us? A very similar thing to what we did with the get. It's going to say the URL and it's going to be performing a post, so an HTTP post. And then what is it going to do? It's going to send the URL, and then it's going to send the talk, which is the body or the JSON body. And then it's going to say the reply of that HTTP call is going to either be an insert talk failure or success. And then the decode here is basically the one that takes the reply and then converts it into our own state. So this is very, very similar to what we did earlier. And then what else do we need to do? There's a few more things we need to do. As I said before, we've inserted. We've already shown how we're gonna deal with how we're gonna send the HTTP post. But as I said, we also need to deal with the subscriptions. We need to deal with the events from the backend. So the way we're going to do is we use the WebSocket library, and then we're gonna say listen. We're gonna be listening for a URL. The URL is basically the localhost 3000 events. And then when we get a WebSocket event, what are we going to do? We're going to fire a new event. So this new talk here is the same, is an event again. So how do we do with the events? We need to go to the update function. And if we go to our update function, we will see that we have here new talk, okay? So if we receive any events from the backend, we have to deal. Now, what do we do in the case of a new event? What we want to do is we want to append it to our front end. So what we need to do is we want to say, hey, I want to take the model, and I'm going to say, now out of this model, I'm going to update the talks, so the list of talks, and what I'm going to be doing is I'm going to be appending a talk to it, and then what is the talk? The talk is going to be appended to the model, so that the talks attribute of the model, and it's going to be the t, which is the parameter here. So it's the talk that we just received. Okay, just so that you see append talk a little bit. Oops. 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 So we can see here, what we do is we basically decode the talk as a JSON, and we add it to, we say, okay, we decoded it correctly, yes, no, and then we add it back. So if we go back here, there's a final thing we need to do, which is show the insert dialog. And that dialog is at the right at the bottom. We've got it down here. We've got the dialog here. So this is, here we are in the view function. The view function, we had the GitHub ribbon, we got the header, we saw the view events, and then now what we need to do is uncomment this part so that it shows us the insert dialog. So if we go back to our browser, if we go a little bit to the bottom of all these talks, okay, we see now here the dialog that we didn't have before. So to save time, I've already preloaded it with some data that of a talk that one of my colleagues, Sanne, is going to be giving in Copenhagen in a couple of months' time. So what we need to do now is all we need to do really is insert this talk. So if we see here, we got it now. It comes back to the bottom. So it's dealt with a new event from the backend. So, but obviously we need to see how do we really have the proof that this came from the WebSocket. Because if we go to the next window, if we go to the bottom, we should see the new talk here as well. It's already present as well. So it's basically been sent to any connected browsers, and they've updated it locally. So, so this is more or less what I wanted to show you in terms of the demos. I've got a couple of two more things that I can show you, but before that, I wanted to a little bit talk to you a little bit more about Elm. So Elm, it's important to understand that Elm has certain limitations. So Elm, just like any other language, has got two priorities at the moment. One is being a great language for building functional reactive UIs, like the one I've shown you here, and it's a language that's very easy to learn. Now, as a result of these two, there's some limitations to Elm itself. For example, there are no type classes. So type classes are a little bit like not like Java interfaces, but it's the ability to say, I want an object to be of this interface, this ability to map, to kind of make an object, implement an interface. That thing is not there in Elm. And the reason it's not there is because type classes bring a lot of complexity to the language. And you can do quite a bit already without them, because there is a high-order functions already available for things like lists and tuples and things like that. But they decided for the time being not to add them. So that means that if you're in Elm, there's a type called dictionary. Dictionary is kind of a key value map. What that means is that because there are no type classes, the dictionary which takes a key that is comparable, this comparable is only implemented by the native types and also the tuples. So that means if I have a key that I want to use in my dictionary, which is foo, I cannot make that foo be comparable. So this, for some people, is a limitation. Also, the fact that there's no type classes means you might end up writing more boilerplate code that you would do normally. In the latest version, there's a concept called signals that went away, which this was a feature that allowed you to take two Elm applications and communicate between them. And then So this kind of ability was there to kind of enable you to compose different applications. The problem is that they found signals was something that people struggled with understanding, so they decided to drop them for the time being. This means that composing multiple Elm applications into one can be a little bit harder. It can still be done, but it's a little bit more work. And another important aspect of Elm is that everything in Elm, Elm can also interact with JavaScript. So if there is any JavaScript libraries out there, you can invoke to them from Elm. The way you do them is via something called ports. But there is, put it this way: if your JavaScript library is small, it's kind of easier to develop, because for each kind of method that you can invoke in the JavaScript library, you have to create a port. So if you have a lot of methods that you have to invoke, there's a lot of ports that you need to implement. So it can be a little bit more cumbersome. So if any of these is a limitation for any applications you're writing, there's always your pure JavaScript, there's TypeScript, or there's also the languages like PureScript, for example, that have got a lot of these limitations are overcome by them. But it's also a more complex language. Elm is a really, really easy to learn language. It's very pedagogic, it's very good for teaching, and everyone kind of understands it very, very quickly. So I still... Sorry, yeah?
Question. Because Elm compiles to JavaScript,
yes.
Will it be possible to run Elm on the server side? Say Node.js import some of functionality that is created in Elm?
In theory, you could, but for the time being, it's more a language designed for building user interfaces. So it's more like one that produces client side. If you PureScript, for example, is a language that is more general purpose language that compiles to JavaScript, and that's the kind of that's a very language if you want to use in the server side. For Elm is more designed for client side, for kind of building UIs.
Just one more quick question.
Yeah.
Does the Elm runtime make assumptions about being run actually in a browser?
No.
Okay.
No. It does have a virtual DOM, so it does have its own DOM engine.
Okay.
But it produces the DOM essentially.
Okay.
But then that normally is the browser, but it could be any other type.
Oh, okay.
Anything that consumes a DOM, really.
Yeah. So. Okay. Thank you. One more.
Yeah, go for it. We still have.
So, how about web views then?
Sorry?
How about web views? Maybe would it be possible to create an Elm application run on Android via these Cordova or Xamarin plugins? Will it be possible?
I don't know off the top of my head. I have not really played with that, so
okay.
I couldn't say. I will need to look.
Okay, thank you.
So before I finish, I wanted to show you. I've got probably about 20 minutes, so I'm gonna maybe spend a few minutes just showing you some of the other parts of this demo. So one of the other things that we can do is, as I said before, in the backend, I have a data grid, right, formed of 3 nodes. So if you go to, let me show you. I want to display. Oops, what have I done? Where are you, pointer? I'm really bad at orientation, aren't I? Okay, that's not it. Oh yeah, it is done there. Hey, there you are. Right. So as I said, I wanted to show you a little bit more what is in the backend. So in the backend, we've got a Infinispan domain, which is created out of 3. Okay, hold on. Let's go here. Oops. Oh. So here, what I have here is a management console from my data grid in the backend. And then I can see that I've got, so let me show you the clusters. Here I've got a cluster which is formed of 3 nodes. So these are the 3 nodes that I have. So we've got, these data grids have got like, you can start a new node directly from here. You can configure caches or like spaces where you store the data. And then, so what we're going to show you a little bit is, as I said before, the backend storage is configured with 2 copies. So it means that if I kill one of them, everything should still work fine. So let's do, we've got here, let's do, oops. So we can see we've got the 3 nodes around here. So let me kill one of them and see what happens. So what is happening in the backend here is that when a node is detected that it falls down, the data that was in that node basically gets rebalanced around the cluster. The idea is that it still keeps the 2 copies that is promised. Okay, so that means that even if we go to our application, we can still connect to it, no problem. Okay, so it's still going to the backend, it can still connect. Other things we can do as well with this application that I wrote is I added a querying capability. So if we have here, I've got the ability to do queries. So what we, oops, let me get my instructions a little bit. So what I want to do now is say, I want to say, how can I find a particular talk that is in the backend? So what I can do, one of the things that we can do is we can take the, we can have like a little dialogue with our query, and then we can assign, when we get our query, we can say, oops, we can update the query in our model, just like we did with others. Okay. So this is like implemented the query field, the ability to update it. Now, once we've got the query field, what we need to do is we need to say, show us the dialogue and show us the results. So for that, we've got here, we got the query talk and the query result. What it's going to do this is going to basically show us a dialogue for viewing, for entering a query, and then that query is going to be sent to the backend, to the middle layer. The middle layer is then going to send that query over to the backend. So if we go now here, we can, it should be reloading already. So now we can start looking for talks. Okay, so we can say, is anyone, any talks happening in London, for example, okay? So we get one of the talks is happening in London. So you can do querying, text-based querying around the entire data. So you can do pretty cool things. And as you see, just adding a query function is very simple. From a UI perspective, it's just a matter of taking the field, putting it, and then doing it with a click. So as I said, I didn't explain it here, but if we have, if we go to the update, we will see that if we do a query talk click, what do? We perform a query talk. And then this one, what it does is like before, it sends an HTTP guest passing the query as parameter. Okay, so it's pretty straightforward. So this is more or less what I had to show you today. There's 15 minutes, which gives us plenty of time for questions. Let me just play it. So to summarize what we've seen today, we've seen today that we wanted to, our objective at the beginning was to learn how to build a functional reactive application. We've seen that functional reactive applications are those that follow the functional reactive programming principles. We've seen why FRP is interesting is because it allows us to build composable systems, and they're asynchronous by default, so there's not really any weight. At no point am I doing any weights or anything like that. And this allows us to build more efficient systems. We've looked a little bit at how to build some parts of our functional reactive application, and I've shown you how to do it, to do live coding on some of those, and how those get reflected. So to finish, I wanted to thank these people that allow me to use the wonderful icons that they've created. And now the important thing about this talk is that everything that you've seen here is available open source, it's in a GitHub repo, so you can go there, try it yourself. It's got instructions of what you need to do to run this in your own homes, so you can play with it. It's got all the setup with all the webcam and everything. Just 1 minute, just go one on the slide. So if you want to do that, and then just some links for you if you want to find out more. Elm Lang to find out more about Elm. Infinispan.org to know more in memory data grids. I've also got a talk